Good evening, everyone. So, in the last videos, I think we had a very clear discussion about queues, right? So, we are discussing about the queues, what are the different types of queues, and what are the various operations that we can able to perform on queue data structure. Okay, like we have implemented a program on normal queue. How you can able to implement that normal queue by using arrays, we have seen very clearly. Okay, next and after that, even how to implement that normal queue by using linked list also we have seen in the last videos very clearly, sir. Okay, next and after that, so circular queue, how you can able to implement a circular queue also we have seen very clearly in our last video. Now in today's session we will talk about a circular queue implementation by using linked list. Okay, let us start. So let us talk about the circular queue implementation by using linked list. Okay, circular queue implementation by using linked list. Okay, circular queue implementation by using linked list. So one by one, step by step process I will explain. Please try to concentrate. Okay. So I'm taking a simple Java program. So I'm saving this file as test.java. Okay. So now listen carefully. Sir, I need to create one special class. Okay, I need to create one special class. So which is named as CQ list. Because in the last videos we have seen circular queue implementation by using arrays. But now we are using circular queue by using list. Okay, so I'm taking CQ list, circular queue list I'm taking. Sir, let us see how you can able to implement this circular queue by using list. Sir, CQ list, in this CQ list, my requirement is nothing but I need to take two special pointers, because whenever we are talking about a queue, you need to declare two special pointers. One is nothing but a friend, another one is nothing but rare. Okay, next I'm taking a class called node. Next I'm taking a class called node, which is having a value, or you can take data anything, and node, sir, which is nothing but next point. And inside the constructor, if you are creating any node, if you are creating any node, compulsory you are going to pass these two values. So we are going to assign these two values like this. Okay, like current object data will become the data which you are giving, and the current object next field will become the next field what you are giving. Like this we are going to declare a special node. Okay, class node is completed. Okay, class node is completed. So next what we are doing here, we need to insert the data. So for that I am taking insert function which will take a data, and that data we have to insert inside circular queue. Similarly, I want to perform delete operation. Okay, so this is nothing but a code for delete. And after this, what is our requirement? So we have to go for display function. This is nothing but the code what we have for display function. Now I am writing insert functionality. So how you can able to insert the data? Have a look once. So here, whenever if you want to create a new node, and that new node has to be attached in a circular fashion. So I'm creating a node, new node is equal to, so new node of with the data field, and the next field is equal to null. Suppose if your friend is equal to null, means what? If it is the only node, I mean, if we don't have any node, then what will happen? So your friend will become that new node. Okay, sir, otherwise if a friend is not equal to null, then rare dot next will become new node. Okay, rare dot next will become new node. So after this your rare will become new node. At the same time, rare dot next will become new node. Like this we have to write, or no, not new node, friend. So I will explain with the help of an example. Have a look once. Suppose consider Suppose consider I have a empty node is there. We don't have any nodes. So means what? Your friend and rare. So both are pointing to null, right? Because we don't have any objects here. Now, sir, I'm inserting a new node. So this is nothing but my new node what we have. Okay, this is nothing but my new node what we have. This is the fresh node. So now this node will become new node. So initially it will check, is your friend is equal to null? Yes, my friend is pointing to null because we don't have any list. So in such cases, what will happen? Your friend will become new node. Okay, so this will become what's up? New node. Sorry, friend. Sir, after this, what we are doing, else part is not executed, rare will become new node. That means this node itself is pointed by rare. And what we are doing, rare dot next is equal to friend. This is the rare, right? Next field is pointing to friend because it is a circular queue, right? Like this we have. So now consider I want to insert one more node. Already one node is there. Okay, this is nothing but that node. So next field is pointing to this beginning, and this is nothing but a friend, and this is nothing but rare, and the content is 10. Now I want to insert a new node. Sir, where that node is going to be added? So here that node will be added. Okay, so here that node is going to be added. So now this will become new node. This will become new node. Consider the data is nothing but 15. Like this we have. Sir, now node new node will become, this is the new node. If friend is equal to null, is your friend is equal to null? No. Then rare next field is equal to new node. This is the rare, right? Its next field will become new node. Then rare is equal to new node. This will be deleted, and rare is now pointing to this new node. And rare tends to next is equal to new node. So by default, this link is also gone. Okay, like this we have. This is nothing but how you can able to assign. Okay, so hope you people got very clear clarity about so this node class, and then how to perform insert operation on this. So can you please confirm, is the circular queue concept, is it clear for you people by using linked list? Right. So next I'm going for the next operation. So what is the next operation here we have is nothing but void delete. So if your friend is equal to null, if your friend is equal to null, means what? There is no nodes in this, right? In such cases, is it possible to delete the objects? No. Simply I'm printing. So queue is empty. My queue is empty, and I'm going to return like this. Sir, if the node is already existed, then what we have to do? Okay, then what we have to do? Very simple. We need to check whether friend and rare both are pointing to the same. Then one situation, otherwise another situation. Sir, if a friend is equal to rare means what? Suppose consider inside my queue, I have only one element is there. I have only one element is there. This is nothing but that element. And this next field is pointing to this one only. And this will become friend, and this will become rare. Okay. Yes, only one item. Sir, as you can see, we have only one item, right? If you have only one item, what we need to do? Just we have to delete this node permanently, right? So for that, what instruction we have to write? Very simple. Your friend will become null. At the same time, your rare will become null. These two we have to assign. Sir, already I have some nodes are there. Okay, so I have some nodes are there, like this is the first node, and consider this is nothing but the second node, and this is nothing but the third node what I have. Sir, now this node is pointing to this one, this node is pointing to this one. Consider I have 1 2 3 data, and this node is pointing to this node, and this will become your friend, and this will become your rare. Like this we have. So delete, right? Which item has to be deleted? 3, because last item, right? No, first in first out. We have to delete first one. One has to be removed. Now see how we are going to maintain. Sir, already we have group of elements are there. So my friend and rare both are not pointing to the same. So in such cases, I am moving friend is equal to, so friend dot next. So that what will happen? Your friend next field is this one. So here it is going to, okay, right. Next, and after that, what is your next instruction? So I am taking rare dot next will become friend. Rare dot next will become friend. This is the rare, right? Rare dot next will become friend. So that what will happen? This is by default deleted. Okay. So by default deleted. This is nothing but how you can able to perform delete operation on circular queue, sir, by using linked list. Can you please confirm, is this structure is clear for you people? Clear? Please confirm everyone. Is it clear? Right. So now we have display function is there. So we know very well we need to take one temporary node which is pointing to front. So if you want, you can check the condition. Suppose if your temp is equal to null, so there are no more nodes in this queue. So I am printing simply message saying my queue is empty, and then we have to return. Sir, otherwise what will happen? Until your temp is not equal to null, so you have to keep on moving that temp. Meanwhile, you need to print the data. Okay, system dot out dot print. So temp dot data, right? Yes, temp dot data, and then space. That's all. And your temp will become, next time temp will become, so temp dot next. So system dot out dot println, just we need to print. That's all. This is nothing but how you can able to perform various operations on circular queue. Now we need to execute this. Let us see how you can able to do this. First, I am going to create a circular queue list. Yes, I am taking queue is equal to new CQ list. Now, so queue dot display. Initially, I am calling display function. Let us cross check, is there any nodes in that or not? So now you can able to see Java C. I am taking test.java. So code compiled fine, and I am taking Java space test. Sir, queue is empty. My queue is empty. So now what I am doing here is I want to insert a certain objects. So queue dot insert of I am taking 111. Q dot insert of I am taking 222. Q dot insert of 333. So Q dot insert of 444. Like this I am taking. Now you can able to see here. Oh my god, oh my god. Where the problem is there? What is happening here? Since it is a circular queue, right? Since it is a circular queue, there won't be null. So keep on repeating, right? Because it is a circular fashion. It is keep on repeating until temp is not equal to friend. Can I take like this? No. So because the temp is initialized with the friend, temp dot next is not equal to friend. Like this we can take. Means what? Suppose consider I have some nodes are there like this. Like this we have. Okay. So this is nothing but a friend. This is nothing but rare. So now what I'm doing here, I'm taking temp is equal to friend. This one. So if it is equal to null, queue is empty. Otherwise, So is temp dot next, is it friend? No. Then print this data and then move temp. So is its next field is equal to null? Not equal to null. Is equal to friend? No. Then print this data and transfer the control. Is it next field is friend? No. Print the data and transfer the control. Is its next field is friend? Yes. So stop. We need to print this value also. So better to print this at last. So here we can able to print, I think temp dot value or temp dot data. So now let us cross check. So you can able to see 311, 322, 333, 344. Perfect. So now if you want, you can insert one more object also. No problem. We are going to get. Now, sir, I want to perform delete operation. So q dot, I am performing delete operation. Okay. Sir, am I printing the item which is deleted? No. I think better to print the item which is deleted. That will be fine. If a friend is equal to rare. So here itself system dot out dot println of. So deleted item is, which item is deleted? So friend dot data. Now you can able to see. Now you can see. So the deleted item is 311. Okay. Sir, can I call one more time delete operation? Yes. Like this we have. Okay. So like this, so we have circular queue implementation. Okay. So I hope circular queue implementation by using linked list, you people got very clear clarity, right? Any doubts up to this? Clear up to this? Please confirm everyone. Right, sir. Now, sir, next concept after this circular queue, sir, we have DQ concept is there. Okay, DQ. So DQ concept is there. Sir, what is mean by DQ? In the case of normal queue, in the case of normal queue, so insertion is from, okay, insertion is from rear side, and so deletion is from front side. Like this we have, right? In the case of circular queue, in the case of circular queue, sir, same operation, right? Insertion is from rear side and deletion is from front side, but all these are attached together. Sir, what about DQ? What about DQ? So DQ is nothing but a double-ended queue. Sir, where we can perform insertion and deletion, where we can perform insertion and deletion from both the sides. Okay, we can perform insertion and deletion both the sides. Beyond that, nothing is there, sir. You can insert the data from the beginning or you can insert the data from ending also. So in this case also, we have DQ implementation by using arrays. DQ implementation by using arrays. Now have a look once. First of all, if you want a diagrammatic representation for this is nothing but what we have. Like this we have. Sir, here insertion we can do here. Okay, insertion we can do here. So deletion we are doing here. This is the normal approach, right? Insertion we are doing here, deletion we are doing here. This is the normal approach, right? And you can insert the data from here also. You can insert the data from here also, or you can delete the data from here also. Means what? Insertion is possible at both the sides. Deletion is possible at both sides. So this is called as a DQ, double ended queue. Okay, this concept is called as what? DQ means double ended queue. I hope you people got a clarity about this DQ. Now we will see how we can able to implement these by using arrays. I'm removing all these things. Okay, and I'm taking a class here. So that the class is nothing but let it be DQ. So DQ by using arrays. Let us see how you can able to work with this DQ by using arrays. Okay. So here, since we are implementing by using arrays concept, you need to take a DQ. Okay, you need to take DQ. Okay, so which is going to hold some objects, and even as usual, front is required, rear is required, and size is fixed, right? So we need size also. Next, and after that, I am taking a constructor. I am taking a constructor where your front is nothing but always -1 and your rear is nothing but always -1. The number of elements in this DQ is nothing but let it be as usual 5. Okay, so I'm creating DQ is equal to, so new DQ, sorry, new integer of how many elements we are going to hold? 5 elements. Like this we have. Okay, so next term, my next operation is nothing but which methods we have to implement. So insert at a front, insert at a front. Okay, from the beginning, how you can insert. So insert at a rear, how you can able to insert from ending. So similarly, so delete from, so delete from front, how you can able to delete from the beginning. Similarly, so delete from end, that means what? Rear, how you can able to insert, delete. Similarly, as usual, how you can able to display the objects. These are nothing but various functions, and here let me provide some value or data which we want to insert into that DQ. Okay, these are nothing but method skeletons what we have. Okay, so yes, here we need to provide size. So can you please confirm, is this a skeleton of this particular class? Is it clear for everyone? Is the skeleton of this particular class, is it clear for everyone? Please confirm. Right, now we will see one by one implementation. So I'm taking insert at a first, insert at a front, how you can able to insert at a front. Sir, here some deeper knowledge is required. Have a look once. Suppose if your front is equal to 0. Okay, if your front is equal to 0, at the same time, rear is double equal to your size -1. This is one case. Or if your rear or if your front is double equal to rear -1. If any one of this condition is satisfied, then we can say my queue is full. Okay, then we can say my queue is full. Like this I am taking, and I will return the control. Sir, this condition is not satisfied. Then what we have to do? Check whether your front is equal to -1. If your front is equal to -1, assign front is equal to rear is equal to 0. So otherwise what we have to do, I am taking front, otherwise if front is equal to 0, then I am taking front is equal to, so size -1. I will explain diagrammatically how it is going to work. Okay, otherwise what we have to do, your front will become already existing front -1, and you have to store, so dq of, so that a rear value, sorry, that a front value will become the value which you want to insert, because we are talking about insert at a front. Sir, here some confusion will be there, please concentrate well. Suppose consider initially I don't have any items, so that means what? Your front value is equal to -1 and your rear value is equal to -1, because we don't have any elements in the queue. So what is the size of the queue? 5, right? So 0, 1, 2, so 3, 4, like this we have. Okay, so 0, 1, 2, 3, 4, like this we have. This is called as what, sir? DQ. Like this we have. Sir, initially front is equal to -1, rear is equal to -1. Sir, is front is equal to 0? No. Is front is equal to rear -1? No. That means what? Q is not full. Is front is equal to 0? Yes. Then this statement is going to execute. Your front and rear both are pointing to 0, sir. Then this statement won't execute. This statement won't execute. Directly DQ of front will become the value which you want to insert. Okay. Now again I am calling insert at the front. Okay. Again I am calling insert at the front. Now I want to insert one more data. Is your front is equal to 0? Yes. Is your rear is equal to size -1? No. Okay, because size is 5. 5 minus 1 is 4. Is it pointing at 4? No. Is your front is equal to rear -1? Is your front is equal to rear -1? Not rear -1, rear plus 1. Is your front is equal to rear plus 1? Rear value is also 0. 0 plus 1 is 1. 1 is equal to 1? No. So it won't execute. Is front is equal to -1? No. Is front is equal to 0? Yes. Then front will become size -1. What is the size? 5. 5 minus 1 means 4. Now onwards, your front is pointing here. See, observe carefully. Front means what? Beginning, right? So the node which you are inserting at the front will be the item first removed, because it is going to follow FIFO technique. The item which you are inserting at the first will be the item which is going to remove last. So that's why, so if you take insert at the front, we are insisting that that element has to be moved first. So here 11 is the first item to be moved. But if you call one more time, sir, immediately I'm going to change front is equal to size -1. So this is the first inserted item. Sorry, this is the 1 minute. This is the first inserted item as of now. So is front is equal to 0. Your front is pointing size -1. That means here now DQ of front will become value. Sir, this value is nothing but considered 12. Okay, sir, which is the latest inserted item? This one. But we have followed which technique? Insert at the front. That means this is the first item in the queue. So this is the second item in the queue. Remember carefully. If you perform delete operation, which thing is going to process first? 12. Because manually we have selected this person and we inserted into the queue at very beginning. Okay, I think you people got my logic. Sir, now I want to insert one more object. Sir, is your front is equal to 0? Yes, no. So is your front plus 1, that is 4 plus 1, is equal to rear plus 1? No. Then is front is equal to -1? No. Is front is equal to 0? No. Front will become front -1. Now front is pointing here, so 13 will be the item. Now front is pointing here, 14 will be the item. Now front is pointing here, 15 will be the item. Like this I am inserting. Now observe carefully. Which is the first inserted item? 15. Second, this one. So third, this one. So fourth, this one. So fifth, this one. Like this we have. Now I am trying to insert one more object. Is front is equal to 0? No. Is rear is equal to size -1? No. Sir, front value is nothing but 1. Is it equal to rear plus 1? What is the rear value? 0. 0 plus 1 will become front. Yes. My queue is nothing but full. We can't able to insert the objects. Okay. So because we are performing insert operation at the front, that is the reason why we have this issue. Okay, suppose if you want to insert a rear as usual condition, no need to check manually. Okay, clear up to this, please confirm everyone. Is the concept is clear? Is it clear? I request everyone to please respond. Clear up to this. Right, sir. So now my requirement is insert at rear. Sir, how you can able to insert at rear? Rear means what? At ending position. As usual, if your front is double equal to 0, okay, So under rare is double equal to size minus 1. Rare is double equal to size minus 1, or if your front is double equal to rare plus 1. If any one of these condition is satisfied, then I am printing the message saying system.out.println my queue is full. You can't able to store any object and return the control. And okay, so next, if your front is equal to minus 1, then we are making front is equal to rare is equal to 0. Else if your rare is double equal to size minus 1, then we are making rare is equal to 0, reverse operation. So else rare is equal to rare plus 1, rare is equal to rare plus 1, okay, and dq of rare is equal to value. Now observe carefully. Like this we have. So initially, first time I'm inserting, your front and rear will be pointing to minus 1. So yes, front is equal to minus 1. Now we have to make front and rear both are pointing to 0th location. These two conditions want to be satisfied. We are pushing the value like 11. Okay. So now we have to perform one more time insertion. Is your front is equal to minus 1? No. Is your rear is equal to size minus 1? Then rare will become rare plus 1. So next item, it is normal insertions. Now rare will become here 13. So now your rare will become here 14. Now your rare will become here 15. So now I want to push one more item. Front is equal to 0. Yes. Rare is equal to size minus 1. Yes. So Q is full. Okay. Like that we have verified. So now it will come out from this. Okay. I think it is very simple. Whatever operation we have performed in the normal queue, same operation we have performed here. Okay, can you please confirm, is this both cases are clear for you people? Clear? Right. Good. So now what is the next operation? Sir, can you please delete from front? Yes. So if your front is double equal to minus 1, sorry, I can't delete the item. Sir, like my message is nothing but dq is empty. dq is empty and then return the control. Okay, otherwise system dot out dot println of I am printing the message saying so deleted. Okay, deleted item is plus I am taking dq of friend. Like this we have dq of friend, and if your friend is double equal to rare, then I am taking friend will become rare is equal to minus 1. Like this we can do. So otherwise we have to check one more condition. What is that condition? If your front is double equal to size minus 1, then we are going to assign front is equal to 0. So otherwise your front will become so front plus 1. Like this we can do. Anyway, I will explain very clearly. Have a look once. Suppose consider I have some nodes are there. Okay, some elements are there. So consider this is nothing but my array with full of elements. So 11, okay, so 22, okay, so 33, okay, 44, okay, 55. So this is 0th location, first location, second, third, fourth. So this is case 1 where front is pointing here, rear is pointing here. So one more case is there, right? This is what insertion at rear. Suppose I inserted the elements by using front technique. Then what will happen? Then what will happen? This is 0th location. So first location. second location, so third location, and then fourth. So this is the first item. Okay, your rear will be there, so front also will be there. Then we are making front here. Then next item, front will be here, front will be here, front will be here. This is front. Two cases are there. Now observe carefully. Is your front is equal to -1? In this case, no. In this case also, no. Is a front and rear both are same? No. Then deleted item is dq of front. If you observe, this is the first inserted item, this is the second inserted item, this is the third inserted item, this is the fourth inserted item, this is the fifth inserted item. But in this case, this is the first inserted item, this is the second, this is the third, this is the fourth, and this is the fifth. So here it is going to delete dq of front. That means 11 is deleted. Okay, so is front and rear both are same? No. Sir, is front is equal to size -1? No. Front is equal to front +1. That's all. Very simple. So here, is your front is equal to rear? The item deleted is dq of a front. This one is gone. 15 is gone. So is front and rear same? No. Is front is equal to size -1? No. Then front is equal to front. Like this we are going to take. This is nothing but how you can able to delete from front, sir. Can you please confirm? Is it clear for you people how to delete from the beginning? I request everyone to please confirm. Okay, right, sir. So anyway, remaining operations I will cover tomorrow, not tomorrow, on Monday, because I have another class is there now. So that's why just I will copy paste this code, and it is incomplete implementation. Okay, incomplete implementation. So we will see about this on Monday's class. Okay. No, sir. No, sir. Tomorrow, actually, I planned for a class, but still some work is going on. That's why tomorrow may not be possible. Okay. Right. Okay, sir. I will upload the running notes within few minutes. You can download. Thank you.